average of a finite amount of objects. Now, if I wanted the average of all of your test scores, what would I do? Add them up and divide by the total number, right? Okay, so if I want the average value of something infinite, if I'm trying to find the average temperature in the day, I can't just add up the temperature every hour and take an average because temperature is a continuous thing, right? So how would I find the average of something like that? We could approximate it if we did intervals, if we took a measurement every 30 minutes and averaged all those, and if I wanted to be more accurate, what would I have to do? I'm going to check it more often, average every 10 minutes, and average every 5 minutes. So we could do that, but we know already that when we are adding up smaller and smaller and smaller rectangles, this is turning into an integral, right? So really, this has to do with the integrals. Our average value, kind of skipped a slide, but that's okay, is 1 over b minus a times the integral from a to b of f of x dx. Okay, if you think about this, the integral from a to b of f of x dx, that's the area under the curve from a to b. 1 over b minus a is the length of the integral. So this is like dividing by the length of the integral. So in other words, this is not really anything new. You're going to be integrating just like we always have. But if I want the average value, then out in front you have to do 1 over b minus a. You have to divide everything by the length of the integral at the end. And that's it. That's our average value. So let's look at a problem. I want the average value of the function f of x equals 1 plus x squared on the interval -1 to 2. So where am I going to integrate from? -1 to 2. Since it's average value, what goes out in front? Right, 2 minus -1 or 2 plus 1. My function is just my 1 plus x squared dx. So that gives me a 1/3 out in front. We can integrate antiderivative of 1 plus antiderivative of x squared from -1 to 2. So if I put those in, the average value of that function is 2. Is that alright for everybody? So let me ask you a question. Is there a number in our interval that would make the function equal to the average value? In other words, is there somewhere between -1 and 2 where f of x is actually equal to 2? Wouldn't there have to be? Why? You found the number. It's at 1. It's continuous. This really has to do with the mean value theorem. Remember we did that? Good final review. Mean value theorem, Rolle's theorem. We were talking about with the mean value theorem that if you had a continuous function, we knew that if you did the slope between the endpoints, somewhere the function had to equal that slope. Right? We talked about Rolle's theorem as well. So this is true, there is always going to be a place, and probably makes a little more sense to read it this way than the second one, where the function is equal to the average value. There will always be a place where that is true as long as our function is continuous, which is something that we need to be able to do the integral anyway. Alright, so you already found that number, but that was my next example. Find all the numbers in the interval that makes that true. So we want to know when our function equaled the average value, which we found to be 2. So if you subtract your 1, it actually happens twice. Both positive and negative 1. And how come I include the negative 1?
Because it's included in there.
Right, it was a closed interval, so we count both of those. So it might happen just once, it could happen more than once. Okay, let's look at another example. Show that the average velocity of a car over a time interval, t1 to t2, is the same as the average of its velocities during the trip. How do we find an average velocity? How do you find velocity in general? It's the first derivative. You know, you can think of velocity like miles per hour. It's a distance divided by a time. So average velocity is just meaning between the two endpoints, like finding the slope between the two endpoints. So it would have to be the change in my distance over the change in my time. Or it would be like the distance at the end minus the distance at the beginning over the ending time minus the beginning time. Just a slope. The overall average velocity is just the slope between two endpoints. Average value so if I wanted the average value of the entire thing, that would be like integrating from time 1 to time 2 the velocity. And if I want average value, you would have to do 1 over t2 minus t1. Okay. But you already said that velocity is just the derivative of your distance, right? Derivative of your position. So instead of velocity, I'm going to call that my d prime. Velocity is the derivative of distance. We know that already. Derivative of our position. Okay. Well, writing it this way makes it really easy to see. The antiderivative would just be the distance at t2 minus the distance at t1. And you get d of t2 minus d of t1, or t2 minus t1, which is the same thing we got for the average velocity. So it's like saying there, if we had just calculated the slope between the two endpoints, we would have gotten the same thing if we had found the average value of the function over the entire interval. Let's go back to some concrete numbers. any questions on this one before we move on?
Did you know you to put like on the bottom one T2 minus T?
Yes, I did, thank you.
So when you deal with the integral of the derivative, you just replace it.
Right, because the derivative and antiderivative cancel each other. Other questions? So find this average value. Can you guys do it on your own? We want the average value, so I have to do 1 over the ending minus the beginning, integrating from 0 to 2 of x squared dx. So that's 1/2 antiderivative of x squared is 1/3 x cubed from 0 to 2. It's 1/6 2 cubed minus 0 cubed, so 8 over 6 or 4 over 3. You guys all get that? Let's look at an uglier one. In Athens, Georgia, the mean daily temperature in degrees Fahrenheit T months after July 15th is closely approximated by this equation. 61 plus 18 cosine of pi t over 6. Find the average temperature between September 15th and December 15th. I need an interval. T is the number of months after July 15th. So September would be 2, December would be 5. So we are going to integrate from 2 to 5. Average value means 1 over beginning or ending minus the beginning. So I have 1/3. Antiderivative of 61 would be 61t. Antiderivative of cosine is a sine. Angle would stay the same. You would have to put a 6 over pi in front, which would bring it to a 108 over pi. Let's calculate it. What mode should your calculator be in? Radian mode. I got 56.8057. Okay, so find this average value on the interval 1 to 4. So I'm going to put what out in front? So I'm just gonna roll from 1 to 4. That's in a 1/2 dx. Grab a 1/3. Add 1 to your powers, so that would be a positive 1/2, so you need 2 out in front. And we should get 2/3 for our powers. Are we good? That's it. By the time you can get your homework done. Okay, so quiz review. I'm not gonna pick any problems from the stuff you're doing right now. I've picked a couple area problems and a couple volume problems. They're odd, so if you want to try some so you can help prepare, those would be the good ones to try.
Thank you. So
Sounds
Mackenzie
good.
Kersey's second page.
It's